All right, let's go ahead and get started here. This is going to be one of our fastest lessons. We're going to be building a repo or a repository or a project that's going to have our own token in it, our own ERC20. And to get started, we're going to go ahead and run the same command we've been running this whole course. Forge init. Oops, excuse me. We're going to run make mkdir Foundry ERC20 F23 clear cd Foundry ERC20 F23 code period, or file open to open this up in a new VS Code here, like this. Then we're going to open up the terminal and run forge init. We're going to initialize a blank repository here. Now, one thing I haven't actually talked about yet is this .github/workflows. This is something called your CI/CD pipeline, and it's a way to automatically test your code in GitHub. Not really going to go over it, but it is a popular tool that a lot of projects use so that whenever they make a change to their code, the test suite automatically runs. And if the test suite fails, the code doesn't get pushed, but that's beside the point. Anyways, we have our basic setup here. We're going to go ahead and delete the 3 of these again. Goodbye, just so we can start from scratch. Now let's go ahead and create our token. We're going to create our own token here, and I'm going to show you a hard way to do it first, and then I'm going to show you a much easier way. So first, let's go in here and let's create a token. So we're going to do new file. We're going to call it manual token.sol. We're going to do the same thing we've always been doing, spdx, license, tab that out. Thanks, Copilot, pragma, Solidity. Thanks, Copilot. Let's use 18, contract, manual token, like this. Now, like we were saying earlier, in order for us to actually implement an ERC20, all we have to do is follow the EIP/ERC token standard. And if we go to the EIPs, we can go to 20, we can scroll down, and all we have to do is add all these methods that they say we need to add. Okay, let's go down. And the first method we need is a name. Okay, so let's create a name. Function name, public view returns string. Okay, cool. So let's go in here. We'll do function name, public view returns string. This is actually gonna be a string memory. And then we'll just say return manual token. This will be the name of our token. Okay, cool. That's it. And this can actually be pure instead of view. Pure got added later. But okay, cool. We have a name. A symbol is optional, so I'm going to skip it. Decimals are optional. I'm going to skip it. Okay, total supply. We need a total supply. Okay, great. So let's do function total supply. Public, we'll make this pure, returns UN256. Let's say return 100 ether. So we'll say this token needs to be 100 ether big. Now, again, since Solidity doesn't work with decimals, we probably should have a decimals function to tell users that this big number, right? Because 100 ether is actually going to be, it's going to be 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8. We probably should have a decimals function. So let's actually create a decimals function. We'll copy this, paste it in here, function decimals, public, we'll make this pure, returns 18. So we're going to tell everybody that the total supply is actually going to be 18. Oh, return 18. The total supply, 100 ether, has 18 decimals. So we know that this big number really is just 100. Okay, great. What next do we need? Okay, we need a transfer. We need a balance of function. Okay, let's copy the balance of function. Let's paste it in here. Zoom out a little bit. And let's turn on toggle word wrap. Okay, function balance of address owner, public view returns their balance. So how do we get their balance? Well, we probably should have a mapping somewhere to map people's address to their balances. So let's go ahead and do that. At the top, we're going to do a mapping of address to UN256 called balances, or this should be S_balances. And we'll make this private balances. And we'll say return on S_balances of the owner. And now you can see just from adding this little piece here, someone's balance is really just some mapping in this token contract, right? That's it. Like somebody has just assigned, you know, if I have 10 tokens in this mapping, it's just going to be my address is assigned to 10 tokens, right? That's it. So holding tokens of an ERC20 just means you have some balance in some mapping in the contract. That's really it, right? So we can keep going. There's a transfer function, right? We could actually do this out and everything. Oh, and yeah, we could probably do, instead of a function stuff like this, we probably could just do string public name equals manual token, right? because if we do a string public like this, it's the same as creating a public function like this. So we can 100% do this. So either one is pretty much the same. There's some gas trade-offs, but I'm not going to go into those now. We could then create a transfer function where we do function transfer. We would say address _2, uint256 amount. This will be a public function. And we would say something like, first we would get the uint256 previous balances. Previous balance equals balance of from plus balance of 2. So the previous balances, actually, if we're going to say from is going to be message.sender. So previous balances of both of them, and then balance of is actually a public. Oops, I'm sorry, this should be like this. We're going to get the previous balances. We'll say balance of from. We're going to do this minus equals, meaning we're going to subtract this amount from them. And then the balance of 2 is going to plus equal that amount. And then we're going to do a require or an assert require balance of from plus balance of 2 equals previous balances or something like that, right? Oh, instead of from, it's going to be, message.sender, message.sender. Right, so it's going to be something like that. And then balance of, oops, this should be parentheses, like this. More parentheses. Oh, I just did all the wrong parentheses. Oh, we actually can't do this. So hold on, s underscore balances. There we go. This is how we should do it. There we go. So we're going to assign those mappings.